Hello! Welcome back to the Remote Sensing Cookbook. Thanks for joining us. In this video, we're going to walk through a workflow where we will generate multiple interferograms for a given co-registered stack of multiple complex SAR images using the multi-reference InSAR operator. Interferometer synthetic aperture radar is a radar technique that uses the phase difference between two complex SAR observations taken over the same region to reveal surface topography or surface motion. Using the phase difference of two complex images, we can create an image known as an interferogram, which can be used in generating digital elevation models or analyzing the ground movement. In this workflow, we'll be using the Sentinel-1 TOPS SLC product. This product can be downloaded from the Copernicus database. The imagery is over Mexico City, and the file names of the imagery used in this workflow can be found in the description section of this video. You can simply search for these file names on the Copernicus database. To begin, ensure that all 4 of the imagery files are downloaded and saved into a local drive, and are extracted. Once that is completed, open Snap. Before we can add in the Sentinel-1 products, we need to process the data. The Sentinel-1 interferotromic wide product has 3 subswaths: IW1, IW2, and IW3. Since Mexico City is located in IW1 subswath, we will need to split the IW product to extract the data for IW1 subswath. To do this, we want to go into the graph builder and create a graph that begins with selecting Read. Then select TOPSAR split, then apply orbit file, and then select Write. You want to run all 4 images through this process you've built in Graph Builder. Also, it is important in the TOPSAR split parameters that you select VV polarization. Once you've run this process through all 4 images, you'll notice that within the Product Explorer, you'll have the 4 imagery files. If you expand the products and select bands, you'll see that there is only IW1 present with 3 different polarizations. The next step is to complete co-registration using S1-back geocoding. The S1-back geocoding operator co-registers 2 or more split Sentinel-1 IW products, with the first product being the reference product and the rest as the secondary products. To do this, go into the ribbon and select Radar. From there, select Co-registration, then select S1 TOPS Co-registration, and finally, select S1-back geocoding operator. Once this is selected, a new window, the S1-back geocoding operator, will appear. Select the square plus to add in the 4 products we had processed earlier. Once all 4 are loaded in, go into the ribbon, then select Back Geocoding, and change the digital elevation model to Copernicus 30 meters Global DEM. Once that is completed, you can hit Run. This process can take some time, so be patient. While this is loading in the back end, S1-back geocoding operator is generating a stack product with 12 bands, with the first 3 bands being from the reference product and the rest from the secondary product. Once this is completed, a new product will appear in the Product Explorer tab. Select the new product, add an elevation band. This can be completed by right-clicking the new product and selecting Add Elevation Band here. Select Copernicus 30 meter Global DEM. Once that is completed, the next step is to run a multi-reference InSAR operator. For this operation, select the stack product we created. Go into the ribbon and select Radar, then Interferotromic, then select Products, and from there, select the multi-reference InSAR operator. Once the multi-reference InSAR operator is selected, a new product window will appear. There are two parameters in this window, the upper part and lower part. The upper part contains the parameters for the interferogram generation and parameters for the additional output band selection. The lower part is the processing parameter tab, which is the reference. That displays the secondary plot, which shows the spatial baseline on the vertical axis and acquisition time difference on the horizontal axis, both relative to a chosen reference product, which is displayed as a blue dot. Other products are positioned based on their acquisition times. For example, a product acquired 12 days later appears 12 units along the time axis. When two blue dots are connected, they form an interferogram pair. The earlier acquired product is the reference, and the later one is the secondary. Multiple products can form multiple reference secondary pairs, which is the basis of multi-reference InSAR. Within the multi-reference InSAR operator, leave the parameters as default and hit Run. The process will take a couple of minutes. Once it is completed, you'll notice a new product within the Product Explore tab. This new product will contain the 4-phase IFG bands, which are the 4 interferograms generated based on this reference secondary plot. The final step we'll go through is to remove any noise from the interferograms. This can be done by using the Goldstein phase filter. To do this, select radar from the ribbon, then select interferotromic, then select filtering, and then finally select Goldstein phase filter. Hit Run and leave the parameters as default. Once this filter is completed, you can open the Phase IFG, which will allow you to view multi-reference InSAR products over Mexico City. Thanks for watching! This tutorial is brought to you by the Remote Sensing Cookbook. Stay tuned for other remote sensing updates and how-tos. Also, be sure to check out our website linked below, and feel free to submit requests and post questions on our forum.